Good afternoon, my name is Ben Lewis, and this is Lab 4 Barg Magnets. So the purpose of this lab was to investigate the strength of a magnetic field with respect to distance, and to compare a computational model with experimental results. So as a preview, the calculated magnetic dipole moment was 0.9616, and the simulated magnetic field of the off-axis measurement had a magnitude of 19.6 microtesla, but the experimental magnitude for the off-axis measurement had a magnitude of 72.4 microtesla. So for this, we need the magnetic dipole equations. That's about really it. And as a procedure, you need to find the magnetometer chip in the phone, align the magnetometer with the x component of the magnetic field, read 0, and then measure on-axis magnitude field and for distances of 20, 70, and 120, 170, and 220 microtesla. And then measure the off-axis magnetic field by measuring the axis distance where the magnetic field is 100 microtesla and applying this distance to the y-axis and measuring the magnetic field at a 45-degree angle. So here are the results in the Excel table. And the magnetic dipole moment was calculated to be 0.9616. And then here's my code for the simulation. It just calculates a magnetic field and then draws arrows based off of the distance. So here's the results and the results of my code. The simulated magnetic, as stated before, the simulated magnetic field of the off-axis measurement was a magnitude of 19.6 microtesla. The experimental was 72.4. And then possible errors, interference with nearby metal objects, inconsistent placement of the phone, and then just the extremely sensitive nature of the magnetometer. So for the what if you hadn't oriented your experiment to compensate for the magnetic north, but instead laid out your meter stick at some immediate angle with respect to Earth's magnetic field, how the results have changed. The Earth's magnetic field would have made contributions to your y and x measurements. Instead of just your y-axis measurements, this makes more tedious to compensate for Earth's magnetic field. So your numbers would have just been off. And then what if your stick had two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? You can expect the fields from the two identical magnets would add to give a magnetic field that is twice as strong as before. This measured distances from the magnetic field strength would increase. This is because the stronger magnet doesn't need to be close for it to have the same magnetic field strength as a weaker magnet. So basically, it would just be making a bigger magnet. Anyway, thank you for watching.